Alright, this video is going to hopefully just be a review of various trigonometry of triangles that you need probably for physics class. So the first thing we'll do is we'll work with the nice special cases of triangles that are called right triangles. Right triangles because they have a 90-degree angle in there. And some of the most basic things we have is if we have side A, side B, and side C. And we can use what we call Pythagorean's theorem, or actually it's kind of a simplified version of Pythagorean's theorem. I'll talk more about that here in a little bit, but Pythagorean's theorem states that the hypotenuse side, which is this right here, the longest side, the side opposite the right angle, that if we square that side, it's equal to the sum of the squares of the other legs. So a squared plus b squared equals c squared. And this is Pythagorean's theorem, and that's a valuable formula that we can use if we have a right triangle. Let's look at some more situations. Let's draw this triangle 3 times here. And whoops, didn't do it as good there, but that's all right. And we'll label it angle A, and we'll do it again, angle A, and angle A. Okay, so what we have here in this situation is we have a certain angle, let's say, that we maybe know, or we're wanting to figure out, either way. And the opposite side, which would be this side over here, is called the opposite side. Tricky, huh? The opposite side. So this side over here is the opposite side. It all depends on what angle. If we were looking at this angle right here, then of course this would be the opposite side. But we're not. We're looking at this angle here, so that's the opposite side. This side here that is right next to the angle, and not the one that's the opposite of the, not the one that's opposite the right angle, but the one that's right next to it right here. Next to, another word for right next to, is called adjacent to. Adjacent. So that's the adjacent side. We'll label that adjacent, adjacent. And then the long side of a right triangle, the side opposite the right angle, is called the hypotenuse. The hypotenuse. Hypotenuse. Okay, and so if we want to determine an angle, if we know the other sides, or if we want to figure out a side, if we know one of the other sides and the angle, then we can use various trig functions. The first one is called sine, and the sine of the angle is equal to opposite over the hypotenuse. So if I wanted to figure out what this angle was here, the sine of the angle, I would take the length of this side divided by the length of that side in my calculator, and then I would hit inverse sine, and I would know what the angle is. I'd be able to figure out angle A. The next one is the cosine of A, and that equals the adjacent side over the hypotenuse. That would mean you take this side, the adjacent side, divided by the hypotenuse, and you take the inverse cosine, and then you would have angle A that way. That's another way to figure out angle A, depending if you have these other sides. And then the third way is called the tangent of angle A, and that is equal to the opposite over the adjacent. So I would take this side, and I would divide by this side, and I'd take the inverse tangent, and I'd have angle A. Those are 3 ways I could figure out one of those angles if I had a nice right triangle. And some trig teacher somewhere came up with this cool saying. So this is, and they made a story about some princess. So sine opposite over hypotenuse, cosine adjacent hypotenuse, and then toa, tangent is opposite over adjacent. SOHCAHTOA is the name of the princess. SOHCAHTOA. And if you can remember that, then you can remember sine, cosine, and tangent. Okay, those are nice simplified cases because you have a right angle, a right triangle. But what if you don't? So we'll move on here, and we'll take some triangle that's not a right triangle. And we have different angles. We'll call this angle A, and we'll call this angle B, and we'll call this angle C. Okay? And what you can do, and so the opposite sides are a, and little c, and little b. Now what you can do with this is you can use something called the law of sines, which is really just a whole bunch of ratios, and this is a pretty simple thing. I'll write it up here so we know. The law of sines. The law of sines. And what that says is that the sine of angle A over the opposite side would then equal the sine of angle C over its opposite side. And that equals sine of angle B over its opposite side, usually. Okay, so all this is a ratio of the sine of an angle over its opposite side. And you could write the whole thing with the side over the sine of the angle. If that was easier for you, you could do something like this. And that would be the same thing. Both of these are called the law of sines. All this law of sines is a ratio of the sine of the angle over the opposite side. So depending on what information you have here, that can be helpful to do. Law of sines, a very easy one to do. There is a special case of the law of sines, and actually I kind of almost drew it here. When you have, like I probably should have drawn something like maybe that. So there's no right angles in there, but they're all acute anyway, all acute. Sometimes you have a problem when you have an obtuse angle in here, and I'll go ahead and show you that real quick, just in case you run into it. This is the law of sines where it doesn't quite work. You just have to, it's called the ambiguous case, and you would have to just know that that's what you're running into, the ambiguous case of the law of sines. Very, very tricky. And in this case, I'm going to make a kind of a special drawing here. I'll draw a nice isosceles here, and then I'm going to kind of extend the triangle out here a little bit. Okay. And I'll kind of draw another little red line right down on there. All right. Okay. So let's say that this here is angle A, and this is angle B, and this is angle C, and we're going to look at the red triangle here, okay? And if that's A, that means that this side here is A, and this side here is little b, and this side here is little c, okay? All right, so what you think you might be able to do is say, okay, then let's say I want to figure out what angle C is. I want to figure out what angle C is. Let's say I know what this little c is. I know what the angle A is, and I know what the other side A is. So what I could do is I could say, all right, then sine, I could use law of sine. Sine of C over little c equals the sine of big A over the little a. And you could cross multiply and divide and take the inverse sine, and you would be able to calculate what C is. But then you might notice something. You might notice that we are trying to find an obtuse angle, an angle greater than 90 degrees, but the angle that you end up getting from this is an acute angle. The reason for that is the law of sines doesn't really work when you're trying to find the obtuse angle. And you got to always kind of realize, make your drawings accurate so you know when you're actually looking for an angle if it is obtuse. You can still use the law of sines, but the angle you get isn't this one. It's actually this one. And if you can look at this, it'll make sense. Instead of looking just at the red triangle, look at the overall triangle, which I'll do in yellow right now. Where this blue triangle here, that's side A right here, but this is also side A right there. It's an isosceles triangle. So if you look at that, sine of A, sine of this angle, over the opposite side, A, well, see, in the red triangle, I thought I was using this, but technically I am using this. See, the outer triangle, sine of A over its opposite side, which is still A. See, that didn't change. Equals sine of C, well, we thought we were using this angle, but we're actually using this angle, over its opposite side, which is still little c. See, that's the little c and the sine of big A and little a, this, and this, none of those actually changed. They are there for this nice big triangle here. And when we find C with this ambiguous case, we're actually finding this C. And it's okay. If you know that you're trying to find an obtuse angle and you do the math and you get an acute angle, that's fine. How are these two angles related? Well, if you just take 180 minus this angle right here, this one, then you'll get the actual angle that you were wanting right here. This angle plus this angle equals 180. So just take 180 minus this angle that you get, your acute angle that you get, and you'll have your actually obtuse angle. So you can still use this. This isn't a big deal. You can still use it. You just need to be aware if your angle is supposed to be obtuse, and you end up getting an acute one. Okay. One last thing, if you don't ever want to mess that up, you can use something else called the law of sines. This will work for any of these triangles. I'll take some big triangle and angle A and angle C and angle B, and then this side would be side A and side B and side C. This formula is called the law of cosines. The law of cosines. Some of you might have used this before, I don't know. And what that says is that, let's say I want to try to figure out line C. So C squared equals A squared plus B squared. Looks similar, doesn't it? Yeah, looks very similar. But we're going to add a little extra onto it, or we're going to subtract a little from it, I guess. Minus 2AB cosine of C, big C. So the first part's easy to remember. C squared equals A squared plus B squared. But then we're going to take minus 2 times the other two sides. We're going to take minus 2 times the other sides times the cosine of the angle in the middle. So to do the law of cosines, I need side angles. We have side angle side, SAS. I need side angle side. So I can take minus 2 times both the sides times the cosine of the angle between the sides. And I can subtract that off. And technically, this is Pythagorean's theorem. This is the real Pythagorean's theorem. It's not the nice little simple one you memorized. The reason we think it is that the simple one you memorize, C squared equals A squared or C squared equals A squared plus B squared, is actually just a simplified Pythagorean's theorem in the special case of a right triangle, right? That's the only triangles it actually works for. This is Pythagorean's theorem, which works for all triangles. And this right here, if we just cut this off to this part, that's what we call Pythagorean's theorem for the special case of a right triangle. And if you think about it, it makes sense, because that would mean that the angle in the middle, C, is a right angle. And right angle is 90 degrees. And what's the cosine of 90? You might know it, or you might not. Cosine of 90 is 0. So if C is actually a right angle, and I put cosine of 90 in there, that means that's 0 times B is 0 times A is 0 times 2 is 0. So it's Pythagorean's theorem minus 0. So see, this true Pythagorean's theorem collapses down to what most people think is the Pythagorean's theorem, even though it's not. This whole thing is Pythagorean's theorem. The one people mostly memorize is only for the special case of a right triangle. But a lot of times we don't have right triangles, so this is the Pythagorean's theorem that we should use. And this has no ambiguous cases. This will always work for all of our triangles. So if you're worried about that ambiguous case of the law of sines, use the law of cosines. It's very helpful. Very, very helpful.